We're now going to talk about how OpenGL interacts with the Windows system, really how GLUT interacts with the Windows system, and how we can define callbacks and control, for example, mouse motion. First, I would like to mention that Windows system interaction is not part of OpenGL. Therefore, you have to use a toolkit. GLUT is the one we use. It defines callback functions for events. This is a very similar architecture to other kinds of programming environments such as X, Java, etc. Therefore, you can define callbacks for the keyboard, for the mouse, for opening, initializing, resizing the window. If you just look at our main function, we had a callback for display, we had a callback for reshape, callback for the keyboard, for the mouse, and dragging the mouse. Let's first discuss the keyboard function because it's a basic example of what a callback function looks like. You have as inputs the key, and then you also have the X and Y coordinates of where the key was pressed, since it may behave differently at different locations. In our case, we do almost nothing with the keyboard. If you hit escape, the ASCII code for escape is 27. That's why I've said case 27. Then I will exit. The reshape is another callback. So if I reshape the window with some width and some height, I set my GL viewport command to that width and height. This is one place where we use GL viewport. Look what happens next. I go to the projection matrix, I load it with the identity, and then I give the GLU perspective command where the only thing I change is the aspect ratio of width to height. Let's look into that in a little bit more detail. First, let's consider this number 30. We know that that is the field of view in the Y direction. So it is the field of view in the Y direction, and that's the first parameter to GLU look at. Now let's consider this next one, which is where W and H really come into play. And we know that width by height, this is the aspect ratio, and that's where they really come into play. So you're affecting the aspect. And this ensures that the image will be filled up and the window will display the image with the proper proportions. The near plane and the far plane. Okay, so I can write that as, let me just write it as N and F. And this being a brief refresher of the different commands or the different arguments to GLU perspective. Note that the model view matrix is not affected because the camera location hasn't changed, and only the perspective matrix or the projection matrix changes. Here is the mouse motion. Let me go over each of these steps in detail. We have the state of the mouse, the button that was handled, the coordinates. If the button is the left button of the mouse, well, if the state is up, you do nothing, but if the state is down, you get ready to begin a drag. And look at the way this is handled. The old X, which is the starting point of the drag, is set to the current value. And what that means is that the drag is relative. When you start pressing the mouse, from that point on, your relative shift will control how the object moves. If you press the right button and it's down, then I just reset GLU lookat. So I reset eye location to its initial value, go to the model view matrix and load the identity and then reset it with my original GLU lookat. Note the command glut post redisplay. This is a very important command, and essentially it tells glut to queue up the display function as soon as possible. This is important because I've changed all my parameters, but now I need to redraw the scene. I will show you a demo of the mouse program. So let's look at my scene. I just have a plane here. I actually have one plane above it, which we've not seen. And what I'm going to do is just move my mouse. So here is the position. I click left at this point in time, and I can zoom in and I can zoom out, and that's relative to where I clicked. Now I'm going to release the button, move to another location and click. Note that nothing happens when I first click. It's only when I drag that it zooms in, and when I drag that it zooms out. Zoom in, zoom out, zoom in, zoom out. So I already showed you the demo of the dragging the mouse, and here's what the function looks like. Notice that the Y location is now given by Y minus the old value, so it's the increment. And the I location increments by some function times the Y location. I don't let it get less than 0, I set it back to 0. After I'm done with this drag, I reset the mouse hold Y, so the drag is always relative to the previous location. Finally, I have to go and set the I location. So I go to the model view matrix, load it with the identity, reset GLU lookat, and queue the display function.